We're going to start out chapter 6 looking at volumes. I'm going to look at volumes using cross sections in a couple different ways. The basic idea here stems from finding the volume of a prism. The basic formula for the volume of a prism is the area of the base times its height. You can see for this first picture here, even if it's an unusual shaped base, as long as you can find the area of that base and multiply it by its height, you have found the volume. We're going to take that idea and extend it into functions, and we're going to see how we can use integration to find volume. The first formula that we're going to look at is based on the idea of a cross-section. So in this picture, we have a solid figure S. It's a three-dimensional figure. And if we intersect it with a plane, we're going to get that two-dimensional shape, which is called the cross-section. And we're going to take that same idea as the volume of the base times the height, but here we're going to take that area of the cross-section and we're going to integrate it over the interval here that we're looking at from A to B. So to find the volume of this solid, you can see the formula here, from the interval A to B, we're going to take the area of that cross-section times dx. So we're going to look at this example. It says the base of a solid is the region between the curve y equals 2 times the square root of sine x and the interval 0 to pi on the x-axis. The cross-sections perpendicular to the x-axis are equilateral triangles with bases running from the x-axis to the curve as shown. So if we look at this triangle here, we need to find the area of the triangle, and then we'll be able to integrate that area over the interval 0 to pi. Area of a triangle is just 1/2 base times height. Well, this is an equilateral triangle, and if we look at this point right here, it's the point that's sitting on the x-axis. It would be the point x0. And this point here that's on the curve would be the point x, then 2 times the square root of sine x. So if we look at the distance between these 2 points, which is just simply 2 times the square root of sine x, that's the base, but we also need to find the height of this triangle. So the height of the triangle is going to run perpendicular to the base. It's going to run down like this. And to find that height, we're just going to use properties of a 30, 60, 90 triangle. So let me draw it down here. I'm going to look at, let's call this the right side of this triangle. Let me try that line one more time because that did not look straight. So here's our 60-degree angle. That would be this angle down here. The height is perpendicular to the base, so that's 90. That makes this upper angle 30 degrees. Since the entirety of the base is 2 times the square root of sine x, you can look at this here is just going to be the square root of sine x. Because this is an equilateral triangle, the height is going to hit the base at its midpoint. And if that's across from the 30-degree angle, then the height, which is across from the 60-degree angle, is going to be the square root of 3 times this amount. So now we have the base and the height of our triangle. So the area is going to be 1/2 base times height. The base, again, is 2 times the square root of sine x. The height is the square root of 3 sine x. So the area, these 2's cancel. The square root of sine x times the square root of sine x is just going to be sine x. So it's going to be the square root of 3 times sine x. So that's going to give us the area of the triangle. To find the volume, imagine this being a three-dimensional shape here. To find the volume over the interval from 0 to pi, we're going to integrate that area. So it's the square root of 3 times sine x dx. The derivative of cosine x is negative sine x. So when we integrate sine x, we'll get a negative cosine x. So we're going to have negative square root of 3 cosine x. And we're going to look at that from the interval 0 to pi. Go ahead and bring that negative square root of 3 in front. So we're looking at the cosine of pi minus the cosine of 0. Cosine of pi is negative 1. The cosine of 0 is positive 1. So in the parentheses, we have negative 1 minus 1, or negative 2. Negative 2 times the square root of negative 3, or sorry, times the negative square root of 3, is going to give us 2 square roots of 3. And then one last thing here before we move on to the next method. There's something called Cavalieri's principle, and it says that solids with equal altitudes, so equal heights and identical cross-sectional areas at each height, have the same volume, even if one appears to be bent or curved. And you could think of it as a stack of coins. If you stacked up 10 quarters and you kind of put a little curve or a bend in your stack of quarters, the ultimate volume does not change.